friends, welcome to my next lecture on stability of linear systems. Let us consider the linear system as usual, dx by dt equal to ax plus by, dy by dt equal to cx plus dy. Now we are going to discuss the case fourth, where the roots lambda 1 and lambda 2 of the characteristic equation are conjugate complex with real part not equal to 0. That means the roots are not purely imaginary. So let us consider this case. Here we shall see that the critical point 0 0 of the linear system is a spiral point. So let us see how we get this situation. Suppose lambda 1 is equal to alpha plus I beta and lambda 2 is equal to alpha minus I beta, where alpha and beta are both non-zero real numbers, that is alpha beta belong to R minus singleton set 0. Then the general solution of the linear system 1 is given by x equal to e to power alpha t c1 times a1 cos beta t minus a2 sin beta t plus c2 times a2 cos beta t plus a1 sin beta t by equal to e to power alpha t c1 times b1 cos beta t minus b2 sin beta t plus c2 times b2 cos beta t plus b1 sin beta t, and a1 a2 b1 b2 are definite constants, c1 c2 are arbitrary constants. First we consider the case when the real part alpha of the roots lambda 1 and lambda 2 is negative. Then we can see from the equation, then we see from here that when alpha is negative, x and y both go to 0 as t goes to plus infinity. So then from 2 we see that limit of x as t goes to plus infinity is 0 and limit of y as t goes to plus infinity is 0, and therefore all paths defined by 2 approach 0 0 as t goes to plus infinity. Now we can write the equations 2 by collecting the coefficients of cos beta t and sin beta t. X and y can be expressed in this form: x equal to e to power alpha t multiplied to c3 cos beta t plus c4 sin beta t, y equal to e to power alpha t multiplied to c5 cos beta t plus c6 sin beta t. And when you do this, that is you collect the coefficients of cos beta t and sin beta t, it turns out that the values of c3, c4, c5 and c6 are given by c1 a1 plus c2 a2, c4 is c2 a1 minus c1 a2, c5 is c1 b1 plus c2 b2, and c6 turns out to be c2 b1 minus c1 b2. Now let us assume that c1 and c2 be real numbers, then this representation of x and y can be further written in this form: x equal to k1 times e to the power alpha t cos beta t plus phi 1 and y equal to k2 times e to the power alpha t into cos beta t plus phi 2. And while doing this, it is easy to see that k1 is under root c3 square plus c4 square and k2 is under root c5 square plus c6 square, and phi 1 and phi 2 are given by the equations cos phi 1 equal to c3 by k1, cos phi 2 equal to c5 by k2, sin phi 1 equal to minus c4 by k1 and sin phi 2 equal to minus c6 by k2. Now let us consider the ratio of y and x. So let us consider y over x. Y is k2 times e to power alpha t cos beta t plus phi 2 and x is k1 times e to power alpha t cos beta t plus phi 1. So when we divide by x, we e to power alpha t will get cancelled, and so k will, let us, if you denote k2 by k1 equal to k, then y over x will be k times cos beta t plus, let us take the difference of phi 1 and phi 2 to be phi 3. So then phi 2 will be equal to phi 1 minus phi 3, and we will have k cos beta t plus phi 1 minus phi 3 over cos beta t plus phi 1. Let us expand cos beta t plus phi 1 minus phi 3, we will have cos beta t plus phi 1 into cos phi 3 and plus sin beta t plus phi 1 into sin phi 3 and divided by cos beta t plus phi 1. So when we divide by this, assuming that cos beta t plus phi 1 is not 0, what do we get? Y over x we get as k times cos phi 3 plus tan beta t plus phi 1 into sin phi 3. Now since the trigonometric functions occurring in 4, okay, you can see here the functions are trigonometric functions, they are periodic. Cos phi 3 is periodic, sin phi 3 is periodic, tan beta t plus phi 1 is also periodic. So, since the 10 trigonometric functions occurring in 4 are periodic, it follows that limit t tends to infinity y over x does not exist. Okay. So, here as t tends to infinity, the limit does not exist, and so what we get, hence the path do not enter 0 0. Instead, the path approach 0 0 in a spiral like manner, binding around 0 0 an infinite number of times as t goes to plus infinity, and hence the critical point 0 0 is a spiral point and it is asymptotically stable as shown in the figure 1, this figure. Okay, you can see they are binding around 0 0 in a spiral like manner and approaching 0 0 in a spiral like manner by binding around 0 0 infinite number of times. Now, so it is a 0 0 a spiral point and it is asymptotically stable if alpha is greater than 0. If the real part of the roots lambda 1 and lambda 2, that which is alpha, is greater than 0, then the solution, we get the same solution, that is we again have 0 0 as a spiral point. The that is the path approach 0 0 as t goes to minus infinity, and the spiral point 0 0 is unstable because the arrows now are reversed. So, the when alpha is of course you are greater than 0, then the again we get the same situation, but the arrows will now be in the opposite directions. So, we have this, and now consider the linear system. An example over on this, dx by dt equal to 2x plus 4y, dy by dt equal to minus 2x plus 6y. So, here a is equal to 2 4 minus 2 6, and so the characteristic equation is a determinant a minus lambda equal to 2 minus lambda 4 minus 2 6 minus lambda equal to 0, and this gives you 2 minus lambda into 6 minus lambda plus 8 equal to 0, or I can say this is 12 minus 6 lambda minus 2 lambda plus lambda square plus 8 equal to 0. So, I can say this is lambda square minus 8 lambda plus 20 equal to 0. So, what do we get? Lambda is equal to minus b, that let us apply that formula, lambda equal to minus b. So, 8 plus minus under root b square, so minus 8 whole square minus 4 into 20 divided by 2. So, we get 8 plus minus under root 64 minus 80 divided by 2, which is 8 plus minus this is 16 minus 16. So, 4i. So, we get 4 plus minus 2i. So, eigenvalues are lambda equal to 4 plus minus 2i. So, they are conjugate complex where alpha is 4, beta is 2. So, alpha and beta both belong to r minus 0, they are non-zero real numbers. Since alpha is greater than 0, okay, the critical point at 0 0 is a spiral point and it is unstable. So, we get a spiral point 0 0 is a spiral point and unstable. Now, let us consider the next case, the last case. The roots lambda 1 and lambda 2 of the characteristic equation are purely imaginary. So, here we will assume that lambda 1 and lambda 2 are purely imaginary, that is their real part is 0. So, we had assumed lambda 1 to be alpha plus I beta and lambda 2 to be alpha minus I beta. So, here in this case, in the case 5, we will have alpha equal to 0. So, here lambda 1 is equal to I beta and lambda 2 equal to minus I beta, where beta is non-zero. So, let us say lambda equal to alpha plus I beta, lambda 2 equal to alpha minus I beta, where alpha is 0 and beta is a non-zero real number. Then the general solution of 1, general solution of 1 we had written as, if you can go to the previous case, this is the final form of the solution, x e by x equal to k1 e power alpha t cos beta t plus phi 1 by equal to k2 e power alpha t plus into cos beta t plus phi 2. So, in the case 5, since alpha is 0, x will be k1 cos beta t plus phi 1, by will be k2 cos beta t plus phi 2. So, this is what we have here, okay, x equal to k1 cos beta t plus phi 1 by equal to k2 cos beta t plus phi 2, where k1, k2, phi 1, phi 2 are as defined in the case 4. Okay, now let us see, since the trigonometric functions in 5, okay, trigonometric functions, let us look at this, the trigonometric functions, because when you open this, what you have cos beta t, then you have cos phi 1 minus sin beta t sin phi 1. Okay, so, cos beta t and sin beta t, they are trigonometric functions, okay, and therefore, they oscillate indefinitely between plus 1 and minus 1 as t goes to plus infinity and as t goes to minus infinity. The path do not approach 0 0 as t goes to plus infinity or as t goes to minus infinity. X and y are periodic functions of t, because cos beta t sin beta t, they are periodic functions. So, clearly x and y are periodic functions of t, hence the paths are closed curves surrounding 0 0. In fact, they are an infinite family of ellipses. Now, how they are an infinite family of ellipses, let us see that. You see x and y, we had come to this form of x and y from this situation, okay, from here we came here. Now, alpha is equal to 0, so we have x equal to k1 cos beta t plus phi 1 by equal to k2 cos beta t plus phi 2. So, when alpha is 0 here, we have x equal to c3 cos beta t plus c4 sin beta t and by equal to c5 cos beta t plus c6 sin beta t. So, let us go there. Okay. So, here we have x equal to c3 cos beta t plus c4 sin beta t and by equal to c4 cos beta t plus c5 cos beta t c6 sin beta t. I can write this system of equations as x y in the form of a matrix c3 c4 c5 c6 and we have cos beta t sin beta t. Okay. So, we have a system of equations. Let me call this as the coefficient matrix of this system. So, A is equal to C3, C4, C5, C6. Determinant of A is equal to C3, C6 minus C4, C5. Let us put the values of C3, C4, C5, C6 from here. Okay. C3 C1 A1 plus C2 A2, C1 A1 plus C2 A2, or I can find here itself. We have the matrix C3 C4 C5 C. We have this matrix. We have A equal to C3 C4 C5 C6. Okay. So, determinant of A we found as C3 C6 minus C4 C5. If you put the values of C3 C6 C4 C5, what do we get? C3 is equal to C1 A1 plus C2 A2, C6 is equal to C2 B1 minus C1 B2 minus C4 is C2 A1 minus C1 A2 and C5 is C1 B1 plus C2 B2. Let us multiply. What do we get? C1 C2 A1 B1 C2 square A2 B1 then we have minus C1 square A1 B2 plus minus C1 C2 A2 B2 and then we have here C1 C2 A1 B1, we have minus C1 square A2 B1, and then we have C2 square A1 B2, and we have minus C1 C2 A2 B2. Okay. Now, what do we notice? C1 C2 A1 B1, this is positive, here it is negative, minus C1 C2 A1 B1. So, this will cancel with this. Okay. And here we have minus C1 C2 A2 B2, here we have plus C1 C2 A2 B2. So, this cancels with this, and what do we get then? A2 B1 times C2 square plus C1 square. Okay. So, we get A2 B1 times C2 square plus C1 square, and here A1 B2 times C1 square plus C2 square. So, determinant of A is actually C1 square plus C2 square into A1 A2 B1 minus A1 B2. Okay. Now, let us look at the situations where determinant of A can be 0. Determinant of A can be 0 if C1 square plus C2 square is equal to 0. Since C1 and C2 are real quantities we are taking, okay. So, if C1 square plus C2 square is equal to 0, then C1 equal to 0, C2 equal to 0, since C1 and C2 belong to R. And when C1 and C2 are zeros, okay, what will happen? C1 and C2 are zeros, we will get C3 equal to 0, C4 equal to 0, C5 equal to 0, C6 equal to 0. Okay. So, C1 C2 equal to 0 imply C3, C4, C5 and C6 all are zeros, and which implies that x is equal to 0, y equal to 0. So, we get a trivial situation. Okay. So, C1 square plus C2 square cannot be 0. Again A2 B1 minus A1 B2 cannot be 0. Okay. This cannot be 0, because we know that this or you can say A2 B1 is not equal to A1 B2. This is the condition we have on A1 B1 A2 B2. Okay. So, this is also not 0. So, the determinant of A cannot be equal to 0, that is what we gather from here. Okay. Now, let us go there. Okay. So, determinant of A cannot be 0, this is what we have found. Okay. So, we can solve this equation by Cramer's rule. So, we get cos beta t equal to we have determinant of the matrix x y, we replace first column of the coefficient matrix by the column of constant. So, x y C4 or C6 divided by determinant of the coefficient matrix C3, C4 or C5, C6. Okay. So, this is cos beta t, and so this is equal to C6x minus C4 by divided by, let me call the determinant of the quotient matrix, determinant of A equal to, let us call as delta. So, this is delta, and sin beta t equal to, similarly we will have determinant C3, C5, C4, C6 column of second column will be replaced by x y divided by delta, and you get C3y minus C5x divided by delta. Now, we have the values of cos beta t and sin beta t. We want to determine the equation of second degree in x and y that results on elimination of t from these two equations. So, sin square t plus sin square beta t plus cos square beta t equal to 1. So, we have C6x minus C4 by whole square over delta square. plus C3 by minus C5x whole square over delta square, this is equal to 1. Okay. So, or we can get C6x minus C4 by whole square plus C3 by minus C5x whole square equal to delta square. So, this when you square these expressions, you will get a second degree equation in x and y. Now, this second degree equation in x and y will represent an ellipse if the coefficient of x y say that is b, okay, and the coefficient of x square is a, coefficient of y square is a, then b square minus ac, if it is less than 0, then it will represent an ellipse. So, let us look at the coefficient of x y that we get from here. So, this is a minus b whole square. So, a square plus b square minus 2a minus b whole square, so 2ab. So, we have a coefficient of x y in the first expression is minus 2c4 c6. Okay. Here the coefficient of x y is minus 2c5 c3. Okay. So, b is equal to minus 2c5 c3. Okay. The coefficient of x y we are denoting by b. So, this is the coefficient of b, and coefficient of x square is what? Let us denote by a. So, c6 square plus c5 square, okay, and the coefficient of y square we are denoting by c. So, c will be equal to c4 square plus c3 square. Okay. Now, let us find b4 minus b square minus AC. So, then what we will get if we have the equals 2hxy, I think we need to take 2hxy, we need not take this 2. Okay. So, 2 that is b is the coefficient of 2xy. So, I think we need not take this 2. So, we have this one c4 c6 plus c5 c3 whole square, b square means c4 c6 plus c5 c3 whole square minus c6 square into c plus c5 square into c4 square plus c3 square, and this will come out to be you can see c4 square c6 square plus c5 square c3 square, and then 2 times c3 c5 c4 c6, and here what we will get c6 square plus c5 square. So, what do we get? Okay, c4 square, okay, c4 square c6 square, and then c5 square c3 square, okay, and then 2 c3 c4 c5 c6, and here what we will get c4 square c6 square, this will cancel with this, and we will get c4 square c5 square, okay, and here we will get c3 square c6 square, and here we will get minus c3 square c5 square. So, this will cancel with this, okay, and what we get now. So, this is minus C3 C6 plus C4 C5. I think it is negative here. Okay. This can be written as minus C3 C6 minus C4 C5 whole square, and C3 C6 minus C4 C5 is delta. Okay. So, minus delta square, and delta is non-zero. Okay. Delta is non-zero. So, this is less than 0. So, this represents x equal to C3 cos beta t plus C4 sin beta t, and y equal to C5 sin beta cos beta t plus C6 sin beta t, which is the solution of the linear system. Okay. They represent an infinite family of ellipses. So, here we have a node, okay, but we have unstable node. Okay. So, So we have a center, this situation we have a center, but it is stable but not asymptotically stable. So we have this situation. Let us consider dx by dt equal to 3y, dy by dt equal to minus x. So here we can see the matrix A is 0 3 and minus 1 0. Okay. A is 0, B is 3, C is minus 1, D is 0. So we get determinant of A minus lambda I is equal to minus lambda 3 minus 1 minus lambda. So we get this is equal to 0. So we get lambda square plus 3 equal to 0. So lambda equal to plus minus I root 3. So the roots are purely imaginary. So the critical point 0 0, as we have already just now discussed, the critical point 0 0 is a center. It is stable but not asymptotically stable. This is the figure here. Okay, you can see 0 0 is a center. Okay, and it is stable but not asymptotically stable. Now nature of roots. So let us consider the first the case where the lambda 1 lambda 2 are both conjugate complex roots, but they are not purely imaginary, that is alpha is not equal to 0. So we had seen that in this case 0 0 is a spiral point, and we had seen that if alpha is negative, then we get the stability as the point 0 0 is asymptotically stable, but if alpha is positive, then the point 0 0 is unstable. And just now we discussed the case where lambda 1 lambda 2 are purely imaginary, that is plus minus I beta. So in that case we had the critical point at 0 0 as a center. It is stable but not asymptotically stable. Thank you very much for your attention.